The topic is finding middle node of a linked list. We want to reach on the middle node. See, as an example, I have taken 7 nodes in a singly linked list here, and this is the middle node. 3 nodes on this side, 3 nodes on that side. If suppose there are only 6 nodes, like this node is not there, assume this is not there, there are only 6 nodes, then which is the middle node? Now, either I can stop on 3rd node or 4th node, right? Any one node I can stop on, because if there are even number of nodes, there is nothing like middle. So either 3rd or 4th, if in a 6 nodes, if you have to find the middle node. Now, what should be the procedure for reaching middle node? So there can be more than one solutions. First solution, find the length. We already know how to find the length of a linked list. We have already seen the procedure. Once you know the length, suppose the length is 7, then reach on middle node, right? Reach to mid node. So which is a middle node? 7 by 2. So this will be 3.5. So we can take it as a seal of 7.2, that is 4th node. So I can take a pointer P upon the first node and move it for 4 minus 1 times. So 1, 2, 3. So 4 minus 1 is 3. So reach till here. So actually I have to reach on 4th node. So this is the 4th node. 4th node means move P for just 3 times. So 4 minus 1 time. If I move the pointer for 4 minus 1 time, then it will reach there. This is one method. So I will not show how to do this one. You know it very well. Just I am discussing the method. See, in this method, first of all, I have to find the length. Then afterwards, I have to take a pointer and move it until it reaches the middle node. So I have to scan the linked list 2 times. No, I want to do it in a single scan. Single scan. How to do it? So let us see the second method. So for finding a middle node in a single scan, we will take 2 pointers. So already we have learned the concept of tailing pointer, that one pointer is there and behind that we will have one more pointer. So for that I will take 2 pointers. Let us call first pointer as P and the second pointer as Q. Now one pointer will move it 1 node at a time, and second pointer we will move it 2 nodes at a time. So let us say P we will move by 1 node and Q by 2 nodes. So in this way, by the time Q reaches the last node, P will be in the middle. So because the distance traveled by P will be half of Q. So let us do it by taking 2 pointers. So already I have taken 2 pointers P and Q. How to do it? Let us do. So first move Q for 2 nodes. 1, 2, 2 nodes. Q is not null. So move P also. 1 node. Then again move Q for 2 nodes. 1, 2. So Q is here. Now Q is not null. So it has not reached end. So move P also. Then move Q for 2 nodes. 1, 2. So Q is here. Then move P by 1 node. Then move Q by 2 nodes. So first node itself Q becomes null. So we cannot move further. Then move P. Shall we move P? No, Q became null. Don't move P. So it means we are on the middle of a linked list. So by using 2 pointers we can do this. So here I have 7 nodes. I'll do it again by taking 8 nodes. Just watch it. Now I have added 1 more node to a linked list. So total there are 8 nodes. So middle node means I should stop at 4th node. So let us see, will it stop at 4th node or not? So 1, 2, 3, 4th node, right? Then 1, 2, 3, 4, 4 nodes that side. Let us run the procedure. Move Q by 2 nodes. Okay, Q is here. Then move P by 1 node. Move Q by 2 nodes. 1, 2. Then move P by 1 node. Move Q by 2 nodes. 1, 2. Move P by 1 node, right? Then move Q by 2 nodes. 1, 2. So Q becomes null. As Q has become null, we are not moving P. I already told you. So don't move P. So Q became null, then stop. P is on the middle of a linked list. So this is the procedure for finding a middle node in a single scan. So this can be done by using 2 pointers, right? Now one thing I would like to show you, that in the previous method, first method, we were first finding length. So just like Q, then we were reaching the middle of a linked list by using P. So same amount of work is done. So amount of pointer movement is same, but only the difference is previous method was not in a single scan. This is in single scan, right? In the previous method, first we perform length, one scan, then second half of a scan. But here, two are done simultaneously. That's it. That is the difference. So if I write the program code for this one, this will be in a single loop. Like P as well as the Q, they will be starting at first, then while Q, means while Q is not null, because who will become null first? Q will become null first. Then what to do? First Q assign Q's next, right? Q will move to one node. Then if Q means Q is not null, then Q assign Q's next. So this is the second movement. Then if Q means Q has not become null, then P assign P's next. So Q will move for 2 times, P will move for 1 time, and P will move if Q has not become null. So this loop will make P point on the middle node of a linked list. So this is a simple code. Now next, analysis. How much time it takes? It takes order of n time. Why? We are just scanning through a linked list once. That's it. So the program code you have to write down. I will not show you the demonstration of this one. You can take a linked list. Already we have programs for creating a linked list. Just you have to write down this piece of code as a function you can write, as well as you can write the same thing inside main function and check it. So after this you can display a node, right? So you can display a node to confirm whether P has reached the middle of a linked list or not. So you can print P's data. So you can know where P is pointing. Is it a 4th node of your linked list or not? So by printing this you can know. I'll show one more method using a stack. I'll remove this. Now third method, I will take a pointer P upon first node and I will take a stack. Now I will scan through this linked list, and each node I will put it inside the stack. So I will put the address of a node, that is 100. Then P will move to the next node, so 110. Then P will move to the next node, it's 130. Then P moves here, right? P is here, so P 150 is inserted. Then P is here, so 200 is inserted in the stack. Then P moves to next node, so 220 is inserted into the stack. Then P moves to next node, so 240 is inserted into the stack. Then P moves to this next node, so 260 is inserted into the stack, right? Then P becomes null, so stop. So we have scanned through this linked list and every address I have pushed it into the stack. I'll complete this one, right? So what is the size of this stack? We can know the size of the stack. 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 by 2. So we want a middle node. So 8 by 2, if I take seal value, then I get 4. So simply pop out 4 nodes from the stack. So 4 addresses, 1, 2, 3, 4. So this is the address of the middle node. So let us try it for 7 nodes. If 7 nodes are there, then I should pop out 3 nodes from this one. Then 4th node will be yes. So I should take it as floor, not as seal. So this also it should be floor. So for 8, floor or seal is same thing. So how many nodes I should pop out is floor number of, that is 8 by 2 or 7 by 2. So if I pop out 3 nodes, then 4th node, that will be a middle node. So this is another method. So take all these addresses inside the stack, then pop out half of the stack, then middle node will be there. So again, this is not using single scan, but we are scanning a linked list only one time, right? But the rest of the process is outside the linked list and it is inside the stack. So we can say we are scanning a linked list only one time, right? So we are getting the addresses from the stack. So this is another solution. So what is the time taken by this one? Time taken is same thing, order of n. Then half of the elements are pop out from the stack, so that's also n, right? Or n by 2, so it is n. So total amount of work done is n plus n by 2 also if you take, it is order of n. That is linear. And one more thing, for writing the program for this one, we should have a stack of linked list, that is nodes type. So these are all pointers to nodes. So you should take a stack of nodes and you can fill the addresses of the nodes in the stack. So try to write on the program. Anyway, in the coming sections, I may be showing a stack of addresses. So that's it. So you have to implement this one. You have to write on a program for this one.